Welcome to Trigonometry for Pre-Calculus Math 11. Today we're taking a look at the sine law. As we move away from the special case of right triangles, we need to develop some techniques that we can use to basically solve a triangle. And what does solving mean? It just means that we find all the missing sides and all the missing angles. Typically when we label a triangle, we do so by naming the angles of the triangle by using capital letters. So you can see in this triangle on the right hand side here, I used capital A, capital B, capital C to name those angles. So triangle ABC would look like that diagram on the right. We can also use small cap letters to denote sides. Typically, again, we use the small cap versions of the angle opposite the side we are trying to label. So there's angle A, so that side over there would be small a. There's angle B, so this should be a small b, and angle C, that should be a small cap C. So what we're going to take a look at is something called the sine law here. Sine law is actually kind of interesting because it's fairly straightforward to prove. What we do is we're going to build a little helper altitude here, a nice right triangle. Make a nice right angle here. And let's pretend that height there of that triangle is x. So what we want to do is, how about we start with let us compare. Let's talk about angle A and angle B. Now this holds true if we drew the altitude a little bit differently, maybe starting off the side A and going up, but this way we can compare A to B, and that should work for comparing C to whatever. So basic trig tells that the sine of A is opposite, which is x, over B. The sine of B is x over small cap A. If we solve for x by multiplying up that B value, we get x there, and we get A sine capital B equals x. Notice because both B sine A and A sine B are both equal to x, they must themselves be equal. And what we can do is, cross multiply, take that B value, divide it under the other side, take the A value and divide it by this side. And we end up with sine of capital A over A equals sine of capital B over B. So that's basically it. That's the sine law. If we did it again, we would see that it would be sine capital C over C. We can make any of those equal. So you see what we have written there, the sine law for any triangle ABC. And that holds true basically for anything, if it's a right triangle or not. So here we have a little question. Determine all the missing sides and angles from the following triangle. Well, angle Q is pretty easy to figure out. If we think of angle sum in a triangle, it has to add up to 180 degrees. If we subtract off angle F and subtract off angle B, we will have 180 minus 50 minus 60 is 70 degrees. So angle Q is 70 degrees. Let me label this side as small cap F. Now we can use the sine law. Let's try looking at that 70 degrees, which is Q. Because Q, we know its opposite side, it's 22. So let's set up the stuff for Q. So Q is sine 70 over 22. And let's figure out angle B, which is 60 degrees over small cap B. So I can cross multiply the B up and the 22 up. And nice exact value, 22 sine 60 over sine 70 will work. And if you roll that through your calculator, we should find out that the value of B is basically 20.275. And our units here, I don't know if we had any units on my example. Nope, so let's go 20.275. So that's side B is 20.275. Why don't you hit pause here, see if you can figure out side F. So let's figure out side F here. Let's go back using the Q information. Sine of 70 over 22 has to be the same as sine of 50 over f. Again, that cross multiplying and solving for f. And again, we should be able to roll this through the calculator and get an answer probably around the same lengths as the other ones. Let's do that, and we get 17.935. So that seems about right. If we look at our picture, the diagram's okay. That's probably not a bad estimate. So the sine law, super useful, really great. There's only one problem though. So if we scroll down to the next page here, one major problem, one kind of minor problem. When we solve triangles using only the sine law, the first problem is that if we are given two sides and the angle between them, we're not able to find the other side of the angles, the other sides and angles only using the sine law. And that's where the cosine law helps here. So you have two sides and you're given the angle between them, can't just use the sine law. The other problem with the sine law is something called the ambiguous case. Now, ambiguous means I don't know if it's this one or that one, so it's a special case where you don't know if it's one type or another. And I have a little picture here, and this problem can arise when we are given an angle, the side opposite the angle, and another side. So what I mean here is, let me highlight this for you. If I'm given an angle, like angle A, and I'm given the side opposite, so little a, and I'm given just another side, say B, I don't know what happens. So there are two different triangles that can be constructed from that information. So notice that if I'm just given A, capital A and little a and B, I don't know if the little a is coming down into the right or if it's coming down into the left, just because the size of the angle allows that piece to kind of pivot along. So is my side B here, or angle B, is it at B2 or is it at B1? So how does this happen? The angle A, the angle that we're given, has to be acute, which means it has to be 90 degrees. If that happens, we can then check to see if the side A is shorter than the other side they gave us. That's really the critical thing. I mean, those two are very important. If that happens, we can pretty well trust we have the ambiguous case. The third thing, the height of the triangle H must be shorter than A. If it isn't, then we don't really have a triangle, so maybe don't worry too much about this. That makes sense. If the side A is shorter than H, we could try and draw a triangle here. That just doesn't quite reach it. So that one doesn't really make too much sense. It wouldn't be a triangle then, and we're probably not going to really give you information which tricks you to that extent. So what I want to do is let's take a look at this example. We'll figure out and pretend that it's the ambiguous case. Determine the side length C in the triangle ABC if the angle A is 30. Okay, so right away there's our first problem, is that angle A is 30. That is less than 90 degrees. So let's call that angle A. I'm just going to draw a general triangle, and then we'll draw another one for the other case. So angle A is 30 degrees. Let me draw that in. Side A is 8, so that's 8 centimeters. And the side B is 13. So let's maybe call this top one here 13. That would mean this is angle B, and that is angle C. So this is one way it could happen. And the way we're going to solve the ambiguous case is we're going to assume that the picture looks like this. And what we're going to do is we're going to solve for sine B. We're going to solve for that B value by going sine 30 over 8 is sine B over 13. If I multiply up by the 13, if we think about we're trying to isolate for B, 13 sine 30 divided by 8 equals sine of B. Roll that through our calculator. We get 0.8125 is sine B. And because these are kind of quadrant 1 angles, we can take a look at just taking the arc sine, or the second function sine of that. That equals angle B, and we figure out that angle B is 54.34 degrees. Now, if angle B is 54.34, we can use, again, angle sum in a triangle. That means that angle C is 180 minus 30 minus 54.34. So angle C is 95.66. So we have a nice angle, 95.66. We can figure out that length C. Let's scoot this up here. The length C, sine of 95.66 over that length C. And let's go with maybe the 30 over 8 again, sine 30 over 8. I'll let you guys kind of cross multiply this stuff and figure it out. You end up with 8 sine 95.66 over sine 30 once you do some cross multiplying, and we get C equals 15.9. And our units here are centimeters. So there's one possible answer, 15.9 centimeters for the length of side C. But let's consider the case where maybe it was the other situation going on. Maybe it was a triangle that looked like this. So again, that's 30 degrees. This is 13 centimeters. That hasn't changed. And this is 8 centimeters. So let me redraw that 8 centimeters a little bit out of the way here. We basically solve this, and if we do anything different, we're still going to find out 54 degrees for angle B. Now, what that tells us is that this angle in here, kind of the complement of that, is the 54 degrees. So that's what we need to remember. We need to remember that when we do the ambiguous case, we end up with 54.34 degrees for B. That works. But it also means that that angle B here, or B2 maybe, let's call that B1, angle B2 is 180. Remember, angles on a line. And we end up with 125.66 degrees for angle B, which gives us an angle C, again, angle sum in a triangle, of 24.34 degrees. And again, we can use our pretty standard sine law here, our sine 30 over 8. Why don't you see if you can solve that for C? Do a little cross multiplying. And from there we can solve for C. So we have 8 sine 24.34. It's nice to carry a few more decimals in these types of calculations, and we can always round at the end. And if you plug that all in, you get 6.59-ish centimeters. So there's two values for C. And what we need to do then for ambiguous case is just solve it normally. We need to make sure we know that the ambiguous case is there. That's the whole angle A and the angle the side opposite. And from there, just consider the two types of triangles. Thank you for joining me today on the Sine Law for Pre-Calculus of Math 11.